Okay guys, today we're going to be learning about Pythagorean theorem. So our objective is students will identify and apply the Pythagorean theorem to find missing sides of a right triangle. So Pythagorean theorem deals with right triangles. So in any right triangle, the sides are called legs, and the side opposite the right angle is called the hypotenuse. So make sure that you fill that out on your note sheet. Okay, so if we look here at this right triangle, it asks us to label the right triangle with the appropriate terms. So right here is your right angle. So the side across from that, we call that the hypotenuse. We will also call it C for short. And then these two sides are called the legs, and the way that I remember that is they make an L for legs. So I'll show you that here with my highlighter. And so this is the first leg and this is the second leg. We call the first leg A and the second leg B. And you can flip-flop those, it doesn't matter. So what I mean is this could be leg B and this could be leg A. The only side that's unique is the hypotenuse because it's directly across from the right angle. So this is a formula that you need to memorize and you need to use to find any side of a right triangle, whether it be a leg or a hypotenuse. So I'm going to highlight that. And so what the formula says is that the leg squared plus the leg squared equals the hypotenuse squared. So for short, we say a squared plus b squared equals c squared. So this is a right triangle, and so we can verify it with the Pythagorean theorem. And I'm going to show you why it's a right triangle. So if you remember, here's the right angle, 4 and 3 are the legs. So 4 squared plus 3 squared, if this is a right triangle, it would need to be the hypotenuse across from the right angle, which is 5. It would need to equal 5 squared. So if we do the math here, 4 squared is 16, 3 squared is 9, and 5 squared is 25. So 16 plus 9 is in fact 25. So since the sum of the two legs squared equals the hypotenuse, the side across from the right angle, that number squared, this is in fact a right triangle. So today we're going to be focusing on identifying whether or not 3 sides make up a right triangle. So we're going to be using, again, Pythagorean theorem. A squared plus b squared equals c squared. So in this first section, 1 through 4, we are trying to decide if these 3 sides make up a right triangle. So we're going to take the 2 shorter sides, we're going to square them, and we're going to add them up to see if they equal the longest side, the hypotenuse squared. So I'm going to write my Pythagorean theorem again right here. A squared plus b squared equals c squared. And I'm going to look at the given sides here. This is going to be my A, this is going to be my B, and this is going to be my C. Remember, C is unique, it's the longest side, and it's the hypotenuse. So to verify whether or not this is a right triangle, I'm going to take 8, I'm going to square it, I'm going to take 15, and I'm going to square it, and I'm going to take 17, and I'm going to square it. If 8 squared plus 15 squared equals whatever 17 squared is, then it is a right triangle. So I'm going to use my calculator if I need to. 8 squared is 64, 15 squared is 225, and 17 squared, remember that does not mean 17 times 17, sorry, that does not mean 17 times 2, that means 17 times 17, so that's 289. So if I add 64 and 225, for this to be a right triangle, it has to equal 289. And so when I add these two, it does equal 289. And so these three sides do in fact form a right triangle. So I say yes. Okay, so let's look at number 12 here. This is 12 is my A, 13 is my B, and 14 is my C. So I need to see, does 12 squared plus 13 squared equal 14 squared? Well, I know that 12 squared is 144. I also know that 13 squared, again, 13 times 13, is 169. 14 squared, 14 times 14 again, is 196. Again, if you do not have these memorized, you need to use your calculator. When I add these, I can already tell that they're not going to add up to 196, but when I add them, 144 plus 169, I get 313. And so since 313 is not the same as 196, which is the hypotenuse squared, this does not form a right triangle. These three sides do not form a right triangle. Okay? So if I look at this next one, I'm going to label this A, B, and C, and I'm going to verify 4 squared plus 9 squared. Does that give me 10 squared? Well, I know that 4 squared is 16. I also know that 9 squared is 81, and 10 squared is 100. When I add 16 and 81 together, I get 97. So 97 does not equal 100. So these three sides do not form a right triangle. Okay, last one here. This is A, this is B, and this is C. Again, how do I know 10 is C? It's the longest side, which we call the hypotenuse, across from the right angle. So we want to verify if these three sides do in fact form a right triangle. So 6 squared plus 8 squared, does that equal 10 squared? Make sure you're showing your work. 6 squared is 36, 8 squared is 64, and 10 squared is 100. When I add 36 and 64, I do in fact get 100. So 100 equals 100. So these are in fact three sides that make up a right triangle. So in that section, we're verifying if these three sides make a right triangle. So this is how we show work to prove. Okay, so now we're going to go to the back side of the notes. And now what you can see in this section is, make sure I didn't skip anything here. Yep, I did not. So we are on section 4. In this part, we're given a picture and we need to find the missing side. Okay, so we're given some pictures and we're given some sides, and then we've got some word problems here. Okay, so for number 1, if I look here, if I look at the side across from the right angle, I'm given C and I'm given A. I'm asked to find a leg B. For these kinds of problems, I want to write down the formula first for Pythagorean theorem, which is a squared plus b squared equals c squared. I want to plug in what I know and work backwards to find what I do not know. So I do know that I have A, which is 6, and I'm going to square it. I do know that I'm trying to find B, so that's going to remain a variable. And I do know that I have C, the hypotenuse, which is 10 squared. I'm going to further simplify this by finding 6 squared, which is 36, and finding 10 squared, which is 100, and I still want to find b squared. So I need to think of my inverse operations. How am I going to get b by itself? I'm going to subtract the constant of 36, and I'm going to get 100 minus 36 is 64. Again, remember, you can use a calculator. But I still have not found b because I have a square. So I have to think of the inverse operation of squaring. So the inverse operation of squaring a number is finding the square root. So the square root of 64 tells me that b is 8. And remember, you always want to include your units, and we are in inches. So what we did in that problem is we were able to find a missing leg. In number 2, we can also find the missing leg, which is A. And we can see that we are given the hypotenuse, which is 5. Again, the hypotenuse is the longest side across from the right angle. So we're trying to find A, we're given C, and we're given B. So again, we start with our formula, A squared plus B squared equals C squared. We plug in what we know. We do not know A, so we're going to keep that A squared. We do know 4 is B, so I'm going to go ahead and simplify 4 squared to 16 to save myself a step. And I do know C is 5, and so 5 squared is 25. Again, I went ahead and simplified to save myself a step. My goal is to find A squared. I need to get A squared by itself, so I need to get rid of the 16 constant. So I'm going to subtract 16. 25 minus 16 is 9, and I'm left with A squared equals 9. I still have not found A because I need to get rid of the square, so I'm going to do the opposite of squaring, which is finding the square root. So the square root of 9 is 3, so I find that A is 3 yards. Again, label your answer with units. So for number 3 and number 4, you are not given a picture. You're just given here a side A, you're trying to find side B, and you're given the hypotenuse. So you can draw a picture or you can input those numbers into the formula. So I'm going to give you guys some time to try 3 and 4 on your own. Okay, so now that you've had some time to try numbers 3 and number 4, you should have gotten for number 3 that B equals 2 centimeters. And for number 4, you should have gotten that B equals 15.7. And there are no units, so we're going to say units. Anytime there are no units, we just use the term units. So for number 4, it was a repeating decimal. It was 15.716, but we're going to go ahead and stop. Again, 15.716. ... We're going to go ahead and round to the tens. So sometimes you may have to round to the tens, the hundreds. You won't know. You will have to read the directions. Okay? So section 5 is now finding the missing hypotenuse. So what we're trying to do here is we're given 2 legs, for example, and we're trying to find the hypotenuse. So the formula looks a little bit different. So I'm going to do 2 of those types of problems so you can see. Okay, so here we're given 2 of the legs. So we're going to do, again, A squared plus B squared equals C squared. And we're trying to find the hypotenuse. So we're going to plug in what we know. So we know 15 squared plus 20 squared will give me C squared. We're going to simplify this by finding 15 squared. 15 squared is 225. 20 squared is 400. And that's going to equal C squared. So now what I'm going to have to do is I'm going to have to add 225 and 400 to give me 625. Okay. And so I get 625 equals C squared. And remember, we're trying to find the hypotenuse. So we want to get C by itself. So we're going to take the square root of each side because that's the opposite of squaring. And we're going to find that the square root of 625, again, you can use a calculator. 625, if you don't have it memorized, is 25. So C equals 25 meters. Don't forget to include your units. So this is an example where there's no picture. I'm going to skip down to number 7. This is an example where there is a picture. So you can see we're looking for the longest side. We're given the 2 shorter sides. Now, if you go back, this is the same example given in the beginning of the notes. So we know it's 5, but we're going to show mathematically why it's 5 centimeters. So 4 squared plus 3 squared has to equal C squared. So these are my A and B, A squared and B squared equals C squared. I'm going to simplify these. So this is 16 plus 9 needs to equal C squared. 16 plus 9 is 25, needs to equal C squared. And remember, I want to get C by itself, so I'm going to take the square root of each side. So C equals 5 centimeters. So this math proves that C equals 5 centimeters. Okay, so go ahead and try 6 and 8 on your own, and then we will wrap up the notes by doing 2 word problems. Okay, so now that you've had time to do 6 and 8, I'm going to give you the answers. So for number 6, you should have gotten 10 feet. Again, remember to label your answer with units. And so C equals 10 feet. And then for number 8, you should have gotten, again, you were looking for C, the hypotenuse. You should have gotten C equals 15 meters. Okay, so let's look at some word problems so we can understand why we use the Pythagorean theorem in real life, or when we use the Pythagorean theorem in real life. So the first question says, Adam is playing hide and seek with Sandra and Javon. Sandra is hiding 12 feet south of Adam, and Javon is hiding 16 feet east of Sandra. How far apart are Adam and Javon? First of all, these are not middle school students if they're playing hide and seek, so let's think about your younger brothers and sisters playing hide and seek. But I think it would be helpful to draw a picture so that you can understand what is going on here. So I'm going to do A for Adam here and S for Sandra. And it says that Sandra is hiding 12 feet south of Adam. So if Adam's right here, Sandra is 12 feet below him. She's right here. South is downward, so 12 feet. And then it says Javon is hiding 16 feet east of Sandra. So if Sandra's right here, Javon is 16 feet east of her. So Javon's over here. And then the question says, how far apart are Adam and Javon? So if Adam's here and Javon's here, this question is asking how far apart are the two of them. And so you can see that this question is asking you to find the hypotenuse. So if you were having trouble with the east and the south, think back to a compass, north, south, west, and east to help you figure out where these children are standing. Okay, so back to the question. How far apart are Adam and Javon? So we're looking for C. So we have A and B, the legs. So we're going to use, again, A squared plus B squared equals C squared. We're going to plug in what we know. So we know A squared is 12 squared. Again, I'm going to skip a step. I know that 12 squared is 144, 12 times 12. And then we've got B squared is going to be 16 squared. So that's going to be 16 times 16, which is 256. And I'm going to try and find C. So since I don't know C, that is going to remain my variable. So now I'm going to further simplify this by adding 144 plus 256. That's going to give me 400. Remember, you can use a calculator, equals C squared. Again, I'm trying to find how far apart Adam and Javon are. I have not found C yet because there is a square. So I have to do the opposite of the square, which is the square root. So I'm going to square root each side. And you find that the square root of 400 is 200. And we go back and look at our units to see what units we need. Sorry, 20. We go back and look at our units to see what units we need. So we are talking about feet, so it's 20 feet. So Adam and Javon are 20 feet apart from each other. Don't forget your units because the square root of 400 is 20. All right, last question, another word problem. So again, remember the strategy is to draw a picture with the given information. You can underline or highlight keywords. So an envelope, number 10, measures 16 centimeters by 12 centimeters. A pencil is placed in the envelope at a diagonal. What is the maximum possible length of the pencil? Okay, so we know that an envelope is a rectangle. So this is what an envelope looks like. I'm drawing a picture here. And so we know that the envelope measures 16 centimeters, that's the longer side, by 12 centimeters, the shorter side. Again, this is not drawn to scale. And a pencil is placed in the envelope at a diagonal. So the diagonal, what a diagonal is it's a line that goes from one vertex, which is the corner, to the opposite vertex. So these are both corners, and this diagonal goes from one vertex to the opposite vertex. And so what you can see here is that the diagonal essentially forms what we know as the hypotenuse, the longest side. We also know that a rectangle is made up of four sides where the opposite sides are congruent, meaning if this bottom side here is 16 centimeters, the opposite side is also 16 centimeters. And if this side right here is 12 centimeters, this opposite side is also 12 centimeters. So now you can see that you're given A and B, and you're trying to find C. So plug in what you know. This ends up being the same exact numbers as the problem above. So you essentially do not need to do the math. We already know that C is going to be 20, but in this case, it's going to be 20 centimeters. However, why did we have to do this problem if the answer ends up being the same? Well, the pictures were formed completely differently because the information given to us was given in two different ways. So when you are doing the Pythagorean theorem word problems, you need to read the information and use it to help you draw the right triangle so that you can see what the question is asking you to find. Is the question asking you to find A or B, one of the legs, or C, the hypotenuse? So to wrap up our lesson for today, the goal of our lesson, again, was to identify and apply the Pythagorean theorem to find missing sides of right triangles. Again, the Pythagorean theorem is down here. A squared plus B squared equals C squared, where A and B are the legs, and C is the longest leg across from the right angle called the hypotenuse. If you don't understand something still, remember you can rewind and rewatch. So hopefully this helped you fill out your notes, and now you can complete the next task. Thank you.